do that a couple different ways. In the Bellwork, we asked you to do it using slope-intercept form. I'd like everybody to be ready because I'm going to ask you to share slope-intercept form with letters when I call them. So no numbers. What does slope-intercept form look like with letters? Right? What does that look like with letters? Ben?
Y equals mx plus b.
Y equals mx plus b. Good. Y equals mx plus b. Where m is my slope, my rate of change of my line as I move along from left to right, and b is my y-intercept. So if I'm going to write an equation for that, the line that contains those points, I need to figure out what m is. I need to figure out what b is. First, let's go ahead and do m. So in order to get m, we can use our age-old slope formula back from middle school. My slope with y's 1s and 2s and x 1s 1 and 2s, what's that look like? What's my slope formula? Marina?
Y sub 2 minus y sub 1 over sub 2 plus y sub 1.
Awesome, thank you. So we can go ahead and just choose one of those points to be point 1, the other point to be point 2, and then we'll go ahead and calculate our slope. So here we go. It looks like I'll choose 3 minus a negative 1 all over negative 2 minus 6. So we'll go ahead and finish our slope calculation. So on top, I get 3 minus the negative 1 is going to be 4. And then negative 2 minus 6 is going to be negative 8. So I'm getting negative 1/2 for my slope. Go ahead and raise your hand if you got that as well. Negative 1/2 for your slope. Awesome, Blossom, great. Let's go ahead and then use that, right? Let's go ahead and use that in my equation for slope-intercept form for m, the slope. I need to figure out what b is. So in order to figure out what b is, I'm going to have to use one of my points and use the coordinates from that point for the x comma y in my equation so that I can solve for my final unknown b. I know what I'm going to put for m. I'm going to put negative 1/2. I'm going to choose one of my points, either one, to be my m and my x, just so that I can solve for a single variable b, and then I'll finally rewrite with y's and x's again for my equation. All right, so which point do you want to use, the first one or the second one? Tyler?
First one.
The first one it is, and so we'll go ahead and rewrite this, except instead of putting y, we're going to put the y coordinate from the first point, negative 1. Everybody, let's do that. So negative 1 equals negative 1/2, that's my slope that I calculated. X, I'm going to use the x coordinate from the same point, so that's 6, and then plus b. In this way, we can write an equation where my only unknown is b, my y-intercept, so that I'll have everything taken care of for my final answer. Here we go. Negative 1 equals 1/2 of 6 is 3, times negative 1 is negative 3 plus b. Adding over my 3, I get 2 for b, so my final answer is going to be y equals negative 1/2 x plus 2. So where did we go to get our slope? Our age-old slope formula, y sub 2 minus y sub 1. All right, all over x sub 2 minus x sub 1. Where did we go to get our b? To get our b, our y-intercept, we had to choose one of our points to represent the x comma y in my equation, just so I could solve for b and then rewrite it again. Y equals negative 1/2 x plus 2. Okay, what questions do you guys have on today's Bellwork question? Today we're going to find a more efficient method for generating the equation of a line, and that will utilize point-slope form. And so our first objective today will be to use point-slope form. In my opinion, that's the most efficient way to write a linear equation. Slope-intercept form certainly works, but it's not the most efficient way if I'm going to write an equation that contains 2 points where one of them is not the y-intercept, because I had to go back and find b, right? I had to go back and find b and then rewrite again. And so we'll at least save one step when we use point-slope form. First, though, we want to go ahead and get your test back, and we want to take care of your homework first. So let's go ahead and do our homework grading first. At this time, if you could take out your assignment number 1, make sure that your top right has your heading, name, 1A, and number 1 clearly labeled. Please give yourself credit for those you completed out 29. And if you need to staple your assignment, go ahead and take this opportunity to staple multiple pages together. There's a stapler over on the side table, and there's a stapler here on the front. Please give yourself credit for those who completed out of 29. Divide, enter, multiply by 4. And if you did your 2 reading questions, then you're eligible for that 5th point. If you just did 1 reading question, then it'd be plus 0.5, a half a point. And then box your infinite campus score, round to the nearest half point, 0 to 5, nice and big on top. Everybody get a chance to staple, so make sure that you have it stapled. And what questions do you have about your infinite campus score? And let's go ahead and do pencils down. And we'll go ahead and check our answers now with our grading pen. And 4 slides today, so 1A is a linear combination. C calculator, 3.5t plus 0.75s plus 1.25k. 4, b plus t equals 5,000, and that's continuous. 5, b plus t equals 12, and that's discrete. So continuous means the graph will be connected, right, for an infinite number of values. Discrete means the graph would be disconnected, right? It would jump in between points. Typically, when we're talking about whole number values like the number of bananas and apples, right, in our practice last time, you're not going to get 6.238 bananas from the store. You're going to get 6 bananas or 7 bananas, but you're not going to get 6.238 bananas. So that relationship didn't exist for all real number banana values. It only existed for whole number banana values. That's an example of a discrete function. In general, discrete, right, relationships are disconnected, right? Disjoint on the graph would be individual points versus continuous would be connected points. Continuous, connected. That's how I remember it. 7a is 5.2x, b 7.8y, c 5.2x plus 7.8y is the combination, the linear combination. The whole equation then set equal to 3.6 and about 0.19 liters. 9a is non-negative integers, b $190, c 25L plus 15s equals 225. You can see the relationship graph in letter D. F 015, 310, 6590 are all points on that linear equation, on that line. 10a, 15c plus 40h is 60. B 3/4 of an hour or 45 minutes. 11 5/3 of a pound or 1 2/3 pounds. 12e exponent. 14, yes, the slope is -1/2. 15a, w equals kh cubed. B is 1 over 4,913. 16a, yes. B, the set of all x's such that x is to the left of or equal to -2 or to the right of or greater than, to the right of or equal to +2, rather. And C, the set of all y such that y is non-negative. The 3, 1a, a line, B, vertical, C, horizontal, 2, standard form, 3, the slope of any vertical line is undefined. We can't measure how much a line rises or falls as you move along from left to right if it's vertical. We can't move along a vertical line from left to right. 4, false, 5a, 9, b, 4, c, there's the graph. 6a, 2.5, b, -2, c, there's the graph. 7a, c over a, there's no x-intercept. B, c over b, there's no y-intercept. 8, 7x plus 3y equals -21, and 9 is 42.
Question.
Yes, Margot?
8 said like see the graph to the right, but there was no graph.
Yeah, there was a mistake with the publisher on that, so sorry about that. You can disregard that one in terms of your accuracy fraction or your completion, or both. Yeah, that was mine. 11a, a horizontal line has slope 0. B, any point that's y-coordinate is 3.5. C, 0 is the slope of any horizontal line. 12, -2x plus y is -3. 13, x is 17. 14, 3n plus 5y is 2. B, there's the graph. C is 0.16 liters. 17.5p plus h. 18.035c plus 0.027h. About 246 miles. 19, 400 minus 60t equals d, and that model's constant decrease. As you're finishing up, go ahead and give yourself an accuracy fraction on a 29, or how many you did. About how many did you get right? In pen, go ahead and circle that. Nice and big on top, make sure your infinite campus score. this box. I'm going to go ahead and pause the recording, and we'll pass in our assignments and then get to your test back. Okay, ladies and gentlemen, let's go ahead and resume our discussion. Take a look at our overarching goals for the day. We're going to find an equation of a line given 2 points on it. That's just like the Bellwork, or given a point on the line and its slope. In a real-world context, we're going to find an equation for a line that contains 2 points, and so we'll do some interpreting today, complete with units. We'll graph, interpret, and model situations leading to piecewise linear functions. So on our practice today, where we're going to earn up to 5 stamps today working in class, you're going to have an opportunity to write some linear equations. And lastly, fit lines to data, which is a super powerful tool that will allow us to take real-world data, develop a linear model for that data, and then use our model to make interpretations or predictions, right, outside of our realm of data. And so that's super powerful. All right, so this is your reading question. It's not on your notes form, but this was from your reading question. Describe when it would be most efficient to write an equation in point-slope form, and when it would be most efficient to use slope-intercept form. Well, point-slope form is most efficient to use when you know a point on the line and the slope, or you know 2 points on the line, and so that's the most efficient way, kind of like Bellwork. I would rather do Bellwork with point-slope form. From now on, we'll see exactly how that will work. Slope-intercept form is most efficient when you know the initial value, that's the y-intercept, and the rate of change, or the slope of the line. And so if you know the y-intercept or initial value and the rate of change, then it's going to be easiest to use slope-intercept form. In our Bellwork question, were we given the y-intercept? Right? Were we given the y-intercept? Are either one of those points 0, comma y? No. And so it was not the most efficient way to use slope-intercept form. We're going to practice using point-slope form. Everybody, in your notes, let's find our point-slope form. If we have a point on the line, x sub 1, comma y sub 1, then the point-slope form of the linear equation is y minus y sub 1 equals m times quantity x minus x sub 1, where m is the same old slope from before, right? It's my instantaneous rate of change. And so let's go ahead and do the Bellwork question again, but let's use point-slope form and compare its efficiency. So we still need our slope m, and so we'll still have to do that calculation between the 2 points. No problem, you guys are very good with that. And so we'll still do our m equals, and it'll be 3 minus a negative 1 all over negative 2 minus 6. That equals 4 over negative 8. And that equals negative 1/2. So we still have to do our slope calculation. However, then we'll go ahead and plug our initial point, x sub 1, comma y sub 1, in for x sub 1, y sub 1 in my equation, and that slope, and then we're done. That is point-slope form. We can rewrite it to compare with slope-intercept form to make sure we got the same answer, but it's much quicker. So let's go ahead and rewrite our y minus y sub 1 is equal to m times quantity x minus x sub 1, where m is my same slope as before, and any point on the line is my x sub 1, comma y sub 1. So if we're going to write point-slope form with this particular problem, which point would you like to use for my x sub 1, comma y sub 1? Right? Which point do you want to use? Well, let's use the same one before. Tyler, did you use the first one? Let's do the first one again so we can compare. Ready? So we'll go ahead and rewrite this. It'll be y minus, my first one had coordinates 6, comma negative 1. So this would become negative 1 equals, my slope was the negative 1/2. And x minus, it'll be 6 is the x coordinate for my first point. And that's it. That's point-slope form, and we're done. That's a linear equation that contains the points 6, comma negative 1, and negative 2, comma 3. We use both points to get m, and then we simply plug one of the points, x sub 1, comma y sub 1, into my point-slope formula. That's it. I can see from this equation that one point on the line is 6, comma negative 1, and the slope of that line is negative 1/2. So I know information about that line just by looking at the equation. Now, if we wanted to compare this, to my original answer to make sure it's the same, then I could go ahead and distribute the negative 1/2 through, combine like terms, and solve for y. So let's go ahead and do that check. This would be y minus the negative is the same as plus 1 equals distribute through negative 1/2 x. Half of 6 is 3, and negative times a negative is a positive. So negative 1/2 x plus 3, and finish it out by subtracting 1 over. My final answer in slope-intercept form would be y equals negative 1/2 x, and then plus 3 minus 1 is plus 2. Let's go ahead and compare.
This is way easier.
Let's go ahead and compare. So how did our slope-intercept form, right, compare with our Bellwork answer?
Same.
I sure hope so. Yes! Negative 1/2 x plus 2. So we got the same thing. However, I would argue that this is way quicker to do it in point slope form, right? It's way quicker to do it in point slope. You still have to do a slope calculation. Then you pick one point and plug it in, but then you're done. All right? If you wanted to rearrange, you could. Either way, you don't have to solve for b and then rewrite. Right? You just have to solve for y. And so it's at least one step quicker, in my opinion. All right, let's go ahead and try then with another one. So write an equation in point slope form of the line that goes through the points negative 9, negative 5, and negative 3, comma negative 7. Please be ready because I'm going to be calling on you to help with the different steps. So firstly, I want point slope form with just letters. So with just letters. Go ahead and tell the class what point slope form looks like. Katie,
y minus y equals m parentheses x minus x.
Excellent, thank you. And so, in order to rewrite our equation, we're going to need to figure out what m is. How do we figure out what m is? Taylor?
Y2 minus y sub 1 over x sub 2 minus x sub 1.
Excellent. So we'll still go and we'll figure out what m is. I know that's y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. I'll go ahead and plug in my values from the points to calculate the slope. Everybody go ahead and do this now. So I'll do negative 7 minus a negative 5 all over negative 3 minus a negative 9. I know that's equivalent to negative 7 plus 5 is negative 2. Negative 3 minus negative 9 is negative 3 plus 9 is 6. And so I'm getting negative 1/3. All right, so are you guys getting negative 1/3? Are you doing the same thing? Awesome. Next, we'll plug that in for m in my equation, that negative 1/3 that we just got. And we'll choose one of my points to represent the x sub 1 comma y sub 1. Which point would you like to use this time? Heather? The first one it is. And so we're going to go ahead and use negative 9 comma negative 5 as my x sub 1 comma y sub 1. All right, so let's go ahead and rewrite that. Y minus the y coordinate from the first point. That's going to be negative 5. So y minus negative 5 equals m times quantity x minus. And we'll use negative 5 for the y coordinate, negative 9 for the x coordinate. And what am I going to use for m, Adam? Negative 1/3, right? There's my slope, right? There's my slope that we already calculated. That's it. That is point slope form. It's easy to see one point on the line, negative 9 comma negative 5. It's easy to see the slope of the line, negative 1/3. And so this is point slope form. Now, we could certainly, right, rewrite this minus a negative as y plus 5. And we could write this x minus a negative 8 as x plus 9. Because on a multiple choice test like the ACT, it's very likely you're not going to see that minus a negative. It's kind of bad math manners to have that minus negative. So this is what you'd see on the answer choices. All right. Lastly, let's go ahead and rewrite in slope-intercept form. So how can we rewrite this in slope-intercept form? So that would be solve for y and rewrite y equals mx plus b. Let's go ahead and do that now. So I'll go ahead and keep my y plus 5 equals, but I'll distribute through the parentheses. So on the right, I get negative 1/3 times x is negative 1/3 x. Negative times a positive is negative, and a third of 9 is 3. I'll finish out by subtracting 5 from both sides. So we get y equals negative 1/3 x. Negative 3 minus 5 is negative 8. So if I rewrote it in slope-intercept form, my answer would be y equals negative 1/3 x minus 8. Awesome. What questions do you have about this one? Let's go ahead and apply our point slope form then to a real world situation. So my pool's been draining at a constant rate, 475 gallons per hour. After draining for 4 hours, there are currently 13,200 gallons of water left in the pool. Let's write an equation using point slope form that will give the gallons remaining y after x hours. Okay, so let's process that for a minute. Here, my pool is draining at a constant rate of 475 gallons per hour. We're going to let y be the number of gallons in the pool. We're going to let x be the number of hours it's been draining. And after 4 hours, there's 13,200 gallons left in the pool. Great. So we've got all the information we need. This is telling me, right, this is telling me a rate of change, which stands for my slope, and it's telling me a point that I know exists within the relationship. So let's go ahead and write my point slope form with just letters again. So point slope form with just letters. What does that look like, Logan?
Y minus y1 equals n times x minus y2.
Good, thank you. Everybody scan the problem and pick out your rate of change. What are we going to use for m, right? What are we going to use for m? So everybody scan the problem and see what we'll use for m, our rate of change. Be ready to tell the class when I call on you. What are we going to use for our rate of change here? Olivia H?
475.
Good. If y is the number of gallons remaining, right, as x hours increases, would my rate of change m be positive or negative? What's happening to the number of gallons in the pool? Is it increasing or decreasing as time goes on? Decreasing, good. So we'll go ahead and grab that negative 475 because the number of gallons y is decreasing as my x variable hours increase. The longer I drain my pool, right, the lesser gallons remain. So I'm going to put a negative there. Good. What are we going to use for our data point, right? What data point exists in this relationship? So what can I use for x sub 1 comma y sub 1? Margot?
4, 13,200.
Yeah, after x, right, x comma y, after x hours is 4, there are 13,200 gallons remaining. Everybody, so we know one point is 4 comma 13,200. Awesome. Now we're ready to go. We have everything we need. This is a one-step deal. Y minus y sub 1 equals, oops, I'm going to scooch over just a little bit, equals m times quantity x minus x sub 1. What am I going to use for m? There's my negative 475. What are we going to use for x sub 1? We're going to use our 4. And what are we going to use for y sub 1? There's our 13,200. That's it. Done. There's our equation that represents that linear relationship. Y minus 13,200 equals negative 475 times quantity x minus 4. Use the equation now to find how long it will take to drain completely. We'll round to the nearest tenth of an hour. So we'll use that information to determine how long it'll take to drain completely. So once again, we'll start with our original. Y minus 13,200 equals negative 475 times x minus 4. When the pool has drained completely, right, how many gallons remain? Right? 0 gallons remain when it's drained completely. So what we'll do is we'll plug in 0 for the gallons remaining. Is gallons remaining my x variable or my y variable?
Wow.
Y. So let's everybody will go ahead and put in 0 for y, and that will allow us to solve for x. So rewrite your entire equation. Except everywhere you see a y, don't put y, put 0, because we want to know how many x hours it took to drain completely, to have the gallons equal 0. And now we'll solve. I get negative 13,200 equals, I'm not going to distribute, because I want to solve for x, I'm actually going to undo that multiplication. I'm going to divide both sides first so that I can get that quantity x minus 4 alone on one side, since I'm just trying to solve for x now. So I went ahead and divided both sides. I divided negative 13,200 gallons divided by negative 475, and I got about 27.789. I'll keep some places here because my final answer has to be accurate to tenths, so I'll keep 27.789. That's more than tenths. And then I'll go ahead and finish it out by adding 4 to both sides. So plus 4 plus 4 looks like 31.789 equals x. So after 31 point, what would we say for nearest tenths? 31.8, and what would the label be for x? Gallons? Percent? Hours. So the pool drained completely after 31.8 hours. That's pretty sweet. What questions do you have about our pool problem? Our pool problem. Okay. The next thing we're going to do is super powerful. We're going to take a given data set and determine the line of best fit. That is a linear equation that models that data. That is a predictor of what other points could adhere to that, the relationship that we see in the data. So we're going to first explain in our own words what it means to fit a line to data and how we could find this line. So here we're thinking about what it means to be a line of best fit. Right? What it means to be a line of best fit. Our second reading question, I asked us to write the steps for using our calculator to find a line of best fit. Today we're going to do it both ways, and that's why you needed a ruler. We've got a grid for you. We're going to find a line, right? We're going to find a line that exemplifies the trend seen in the data, right? We're going to find a line that's closest to all the points at one time, even though it might not go through any of them. So let's go ahead and do this by hand first. We're going to plot the following data points on the coordinate grid, and then we're going to estimate a line of best fit visually by using our ruler. So we're going to plot and then estimate the trend line by using our ruler. Everybody, let's go ahead and plot these on your graph paper. So on your grid. We provide one on your note sheet. Let's go ahead and carefully plot these. So negative 8, 8, negative 5, 7, negative 2, 6, 1, 6, 2, 3, 6, 2, 9, 2. So we went ahead and plotted these points. Make sure that you have yours carefully plotted. And now what we're going to do is we're going to take our ruler and we're going to estimate the line of best fit by considering what line could I place there that would be closest to all those points all at once, right? That is, minimize the distance between my trend line and each of the points. So I want to place this such that it exemplifies that trend. And as I look at this line, I think, it's not too bad. Maybe I want to make it a little bit flatter. Something like that.
Yeah.
All right, so I'm going to try that. I'm going to go ahead and put my ruler there. I'm going to try that.
Okay. Maybe a
And a little steeper.
the line runs like.
Oh, That's a little better, isn't it?
So it goes between the second to last.
How about that? Closest to them, right? It doesn't have to go through any of them, but I want to exemplify the trend. So what I'm trying to do is minimize all the little distances between those points and the line, right? So I'm visually doing this. I'm just guessing. I'm estimating. But I'm doing so that each of these distances back to my line that I draw would be minimized. So that's my goal here. So we'll try this one. Maybe this will be a little bit better. That's pretty darn good. All right. So let's go ahead and see. I'm now going to identify two actual points on my line. They don't have to be on the data set. They might be on the data set, but I'm going to pick 2 points on this line. I'm going to use that to write a linear equation. So I'm going to go ahead and scan my line, and I'm going to find 2 points on it. I'm going to pick this one and this one. In that first point that I circled, -2, 6, that's actually in my data set. It doesn't have to be. I just tried to pick 2 convenient integer points so I could do my slope calculation and write the line. So it doesn't have to be in the data set. I picked this point. Notice this point. Is this point in the data set? No, it's not in the data set at all. It's just I'm choosing it because it's convenient. It's an integer value. So I'm going to go ahead and choose 2 points on my line and write those down. So I have -2, 6. And I have 8, 2. So -2, 6 and 8, 2 are on my line. Your line might be different. Please pick 2 integer points that are on your line. If they're the same, great. And if they're not, that's okay. -2, 6 and 8, 2. All right, so I've got my 2 points. Now I'm going to go ahead and generate the equation of my line using those points that I selected. So let's go ahead and do that now. What do we need? Well, we've got 2 points, so let's go ahead and calculate my slope and use point slope form. So m equals y2 minus y1 all over x2 minus x1. So m equals 2 minus 6 all over 8 minus a -2. So m equals -4 all over 10 or -2/5. Next, I'm going to go ahead and generate the equation by starting out with point slope form. So y minus y1 equals m times quantity x minus x1. And we'll plug in our value for m that we calculated, -2/5. And we'll plug in one of my points on the line for x1, y1. What would you guys like to use for x1, y1? Which point do you want to use for this one? Margot? 8,2, I'm down. So let's go ahead and rewrite. Here we go. Y minus 2 equals, m is -2/5. Right, -2/5 times quantity x minus 8. There's point slope form, right? There's point slope form. If I want to go ahead and write this in slope-intercept form so that I can compare it with my calculator, I'll go ahead and solve for y. So for my line, I would get y minus 2 equals -2/5 x plus 16/5. Adding over 2 to solve gives me y equals -2/5 x plus 16/5 plus 10/5, because 2 is 10/5, equals 26/5. And so that I can compare this with my calculator, right, my calculator's answer, I'm going to say y is given by -0.4. Well, I better do 0.4. And then that would be 5 goes into 26 5 times with 1/5 remaining. So 5.2 and we'll compare this with our graphing calculator in the second part of our activity. Your equation might be different, but if you went ahead and solved for y, it should be similar slope values, right? I got negative 0.4 and similar y-intercept. Let's see if that's reasonable. 5.2, is that a reasonable y-intercept for my line? It is. Negative 0.4, that's close to negative a half. It looks like I'm going down 1/2. Yes, that's reasonable for my rate of change. Now let's do it with the calculator so that we can compare. This is my favorite. One of my favorite things to do with our graphing calculators in advanced algebra is do a regression. A regression is where we use the built-in software of our calculator to determine our line of best fit numerically. We're going to compare that with what we did by hand and see how well we did. So for your reading question, we know to use our graphing calculator to develop a line of best fit, we'll enter all our x's in the list 1, that's in our stat menu. We'll enter all y's in list 2, that's in our stat menu. And then on our home screen, we'll do stat calculate linear regression. If we want to automatically store our regression equation in our y = menu for the graph, we're going to go ahead and include bars, y bars, function y1, and then our linear regression before pressing enter. Or after our linear regression, I should say. Don't worry, we're going to do all these things together. So at this time, I need everybody to find their calculator. We're going to go ahead and enter our data points into our lists using our statistics menu. So everybody, we're going to go ahead and enter these into our data. So what we want to do to be a good calculator neighbor is we want to clear out any existing functions in our y = menu. We want to turn off any plots that are on. We can do that by highlighting the plot and pressing enter so that it's all whited out. So you should have no functions in there and no stat plots on. Is everybody good? Next, we're going to go ahead and enter our data into our lists. In order to do that, we use the stat menu. So everybody find stat. Everybody press stat. Edit. And we're going to go ahead and enter our points, x values in list 1 and y values in list 2. So if you have existing data, you can clear it out by up arrowing and pressing clear. And then down arrowing, you can up arrow to highlight the list title and press clear, and then down arrow, and your list should be all cleared out. So everybody stat, edit, and then make sure your list 1 and list 2 are blank. Everybody good? Now let's enter our x coordinates in list 1 in order. So ready? Here we go. Our x coordinates go in list 1 in order. That means we're going to do -8, enter. -5, enter. -2, enter. Everybody do it. 1, enter. 2, enter. 6, enter. 9, enter. We've entered all of our x coordinates from each point in order in the list 1. Now we're going to go ahead and enter my corresponding y coordinates in order in list 2. So that was stat, edit, and now in list 2, I'm going to go ahead and put in the corresponding y coordinates. 8, 7, 6, 6 again, 3, 2, 2. Make sure that you have the same number of x values and y values, otherwise you'll get an error dimension mismatch when you go to make a stat plot. So do we have the same number of x's and y's? Or do our points match? Okay, go ahead and show your calculator this table. I'm sorry, show your partner this table in your calculator. Make sure you guys have the same thing, so we're on the same page. Everybody good? Awesome. Here's where it gets really cool. So what we're going to do is we're going to go ahead and make a scatter plot now, a scatter plot of my data. So we're going to go ahead and zoom 6 to return to my standard viewing window. That's -10 to 10, because on my activity we had -10 to 10. Yep. So we're going to make the same window. So we're going to zoom 6, and now we're going to go ahead and turn on our stat plot. So in our y = menu, if we haven't messed with our defaults, we can up arrow to highlight plot 1 and press enter to turn it on. So we're going to go highlight and turn that plot 1 on. So y = up arrow, plot 1, enter, down arrow, and it should be highlighted now. Everybody good? Highlighted? Now when I go to graph, watch what happens. Voila! Our calculator has plotted those data points, which pairs x coordinates from list 1 with comma y coordinates from list 2 and plotted them together on our graph. So how does it compare? There's our plot. All right, there's our plot. We did it by hand. We did it with the graphing calculator. So I'm feeling good about the scatter plot, but that's not as powerful now as the line of best fit. And so to get the line of best fit, we're going to perform a regression. In order to do that, we're going to use linreg for linear regression, ax plus b, in the stat menu under calc. So let's go ahead and try that together. Everybody listen carefully. So we're going to go stat again, but this time we're going to right arrow over to the calc menu. So everybody stat, right arrow to the calc menu, and now we're going to go to linreg, ax plus b. So that is stat, calc, linreg, enter, and the command will come up on your home screen. I like to add the additional requirement of storing my regression equation automatically in my y equals menu. So if I want to store it automatically in my y equals menu, I'm going to store my regression equation and tell the calculator that by pressing vars. Everybody find vars, variables, right here. Y variables. Function, enter. And y1, I'm going to store it in y1. If you don't have this screen because you have an 83 that you're borrowing, after linreg you can do the same exact thing. Vars, y vars, function, y1, enter. And now we can go ahead and calculate it by pressing enter on calculate or enter on your home screen. And voila, the calculator will spit out the slope, that's my a, plus b is my y-intercept, and tell me what my equation is. Let's see. My calculator told me that y equals about negative 0.39 x plus 5.02. When we did it, by hand, what did I get?
2/5.
So I got negative 0.4x plus 5.2.
Super close.
Gosh darn it, that's pretty close. Copy.
Pretty dang close.
Paste. I'm not going to do the right click because I messed up yesterday. So this was our by hand. And I'll go ahead and do a versus. And ours is all pretty good. The calculators is better because it minimizes the distance you're using the points. And now watch this. Guys, if you stored it in your y equals menu, it'll already be entered with the decimal places. So you don't have to copy all those decimal places down and retype it in there and run the risk of messing up. It'll already store it. Look at all that. It already stored. So when I press graph, what's going to happen? It'll make my plot and woo! It's going to graph my line of regression against the backdrop of my scatter plot. That's awesome. So now I've got that by hand and I've got this with the calculator. So much nicer. So much nicer. So we definitely want this. That's pretty sweet. All right, so let's go ahead and review our commands. Everybody, let's review our commands. So here we go. We went stat, edit. We entered our x's in list 1, our y's in list 2. Then we went stat, calculate, and we did our fourth option, linear regression. Everybody do it again. We paired list 1 x's with list 2 y's, and we stored our regression in y1. We did that by doing variables. Everybody try it. Variables, y variables, function, y1, and then calculated our regression line. On the home screen, it calculated it, but it stored it automatically in my graphing y equals menu. How sweet is that? So now I've got both things working for me. I've got the scatter plot and I've got my line of best fit. We're going to be using that during your activity today to generate your stamped exercises on the back page. 1B, 1D, and 2B all come from calculator lists and stat calculate linreg. All right, let's go ahead and put it all together then for our closure. Write the general equation for point slope form. Don't say it out loud and then tell why it's useful. We're going to write an equation in point slope form with a line with slope -2 that contains the point -3, 5. That'll be right off of your practice as you get going. We'll rewrite that equation in slope-intercept form. And then lastly, let's go ahead and write down our steps for regression. So we just did, how will we generate a regression line for data? So I'll be looking for a response on everybody's closure and be ready to share with the whole class when I call on you. Everybody on your closure, good. Thank you. Here's our general equation for point slope form. And why is it useful? Write an equation in point slope form that contains that point with that slope. Rewrite in slope-intercept form so we can compare. And lastly, we'll list our steps. Okay, let's go ahead and share some of our initial responses, and then we'll go ahead and make sure that we have the correct steps for our grapher. We'll need that for our activity in just a minute. So, firstly, what's the general equation for point slope form with letters? So what does that look like with letters? Okay, Cody.
Y minus y equals
Good, thank you. And why is this form useful? Well, it's the easiest way to generate a linear equation. So it's easy to find the equation of a line when I use a point slope form. So it's easy to find the equation of a line if I use point slope form. Thank you. Let's write an equation then in point slope form of the line with slope -2 that contains the point -3, 5. It's as easy as rewriting my green point slope form, except I'll substitute in -2, my slope in for m, and I'll substitute in my point values x1, y 1 in for x1 and y 1. It's that easy. So let's go ahead and do it. 20 y minus 5 equals my slope times quantity x minus x1. So for us, that's m is -2. The x coordinate is -3. So y minus 5 equals negative 2 times quantity x minus a negative 3. And of course, we'll rewrite that minus a negative so that it looks better. Our final answer in point slope form will be y minus 5 equals negative 2 times quantity x plus 3. Right? We minus a negative is bad math manners. So this will be my final answer. At this time, go ahead and raise your hand if you already had that. So who already had y minus 5? Way to go, you guys. That's perfect. So how quick was that? 1, 2 steps. Right? If I know a point on the line and its slope, I can write slope point slope form right away. Now let's rewrite in slope-intercept form so we can compare it. To do that, we'll solve for y. So y minus 5 equals negative 2x, distributing through the parentheses. Negative 2 times positive 3 is minus 6. Therefore, y equals negative 2x, and negative 6 plus 5 is simply negative 1. So it looks to me that y equals negative 2x minus 1 would be my slope-intercept form. And lastly, let's go ahead and list our steps then for using our calculators to generate a regression line for data. So what do? Well, we'll go ahead and go to our graphing calculator and we'll go to the stat menu. So stat, edit, input x's into list 1, y's into list 2. So what do? We do stat, button, then we do edit, then we do x's in list 1 and y's in list 2. Then what do? Well, then we do stat, but now not the edit button. We're now going to do the calc menu. So we went right over to the calc menu, and in the calc menu we selected the fourth option, which was linreg, linear regression, and then we stored our equation. Right? We stored our equation in bars, y bars, function, y1. And lastly, enter. And it spit out our y equals ax plus b. And stored in our y equals menu. This step in black, bars, y bars, function y1, is optional. You don't have to store it. You can still do your regression. You just have to copy down your decimals on your home screen. However, this stores it automatically in your y equals menu and writes all the decimals in for you so that you don't lose accuracy or miscopy or have to re-enter in your y equals. That's why I encourage you to store your regression equation every time you perform linear regression. What questions do you guys have about our calculator steps? Then now you're going to have a chance to practice both with point slope form, slope intercept form, and regression lines by earning stamps, up to 5 stamps today, in number 7A, 16, side 2, 1B, 1D, and 2B. Again, I ask that I'll record your OTL stuff. Go ahead and come up to the front table then when you're ready for a stamped eligible, and you may work with a partner so long as you're quiet and on task. You can work with a partner to earn these. Thanks for getting going right away, and I'll go ahead and save the recording now.